Hey there, science fans! Today we're going to talk about something truly amazing. Helicopters. You see them in the sky, these incredible machines that can fly up and down, move forward and backward, and even hover in place like a hummingbird. But have you ever wondered how helicopters actually work? How do they manage to perform such complex maneuvers with such precision? What makes them different from airplanes, and how do they manage to defy gravity? Unlike airplanes, which generate lift through fixed wings, helicopters rely on rotating blades called rotor blades. These blades are specially designed with an airfoil shape, similar to airplane wings, but they're attached to a rotating mast atop the helicopter's fuselage. This unique design allows helicopters to have vertical takeoff and landing capabilities. When these rotor blades spin, they create an upward force called lift, which is what allows the helicopter to lift off the ground. The faster the rotor blades spin, the more lift they generate. This lift is crucial for the helicopter to rise into the sky and stay airborne. But how does the pilot control this lift? To control the amount of lift, and therefore the helicopter's altitude, the pilot can adjust the angle of attack of the rotor blades. This adjustment is key to managing the helicopter's flight path and stability. This is done using a control stick inside the cockpit, which tilts the swash plate, a device that changes the pitch of the rotor blades as they spin. The swash plate mechanism is a marvel of engineering, allowing for precise control over the helicopter's movements. So, the next time you see a helicopter in the sky, remember that it's not magic, it's science. These incredible machines use the principles of lift, thrust, and control to achieve flight, and they rely on some pretty fascinating physics to do so. Helicopters are not just about flying, they are about mastering the art of controlled flight. They can perform tasks that airplanes cannot, such as hovering in place and vertical takeoffs and landings. Let's delve deeper into some of these principles, starting with coning and centrifugal force. These forces play a significant role in the stability and performance of a helicopter during flight. Now let's talk about something called coning. Imagine spinning a top. As the top spins faster and faster, you'll notice that its top begins to rise, forming a cone-like shape. This happens because of centrifugal force, the same force that pushes you outward on a merry-go-round. The same thing happens with helicopter rotor blades. As the blades spin rapidly, centrifugal force tries to pull them outward. This force causes the blades to rise slightly, forming a cone-like shape. This upward movement is called coning. Coning is an important factor in helicopter flight because it affects the stability and lift distribution of the rotor system. If the blades cone too much, it can reduce the efficiency of the rotor system and even lead to instability. To counteract the effects of coning, helicopter rotor blades are designed with a certain amount of flexibility, allowing them to flap up and down slightly as they spin. This flapping motion helps to distribute the lift evenly across the rotor disc and maintain stability. Centrifugal force also plays a crucial role in keeping the rotor blades extended. Imagine holding a weight attached to a string and spinning it around. The weight will try to fly outward due to centrifugal force. Similarly, centrifugal force acts on the helicopter rotor blades, pulling them outward and keeping them extended during flight. In the next section, we'll explore another fascinating phenomenon that affects helicopter flight, the Coriolis Effect. Get ready for another exciting ride. Let's imagine you're on a merry-go-round, spinning around with the wind in your hair and the world blurring around you. Now you try to throw a ball straight to your friend on the other side, who is also on the merry-go-round. You might think the ball will travel in a straight line, but it won't. Instead, it will follow a curved path. The ball will appear to curve as it travels, as if some invisible force is pushing it off course. This is because the merry-go-round is rotating. This, my friends, is the Coriolis effect in action. It's an inertial force that acts on objects moving within a rotating frame of reference. The Coriolis effect is not just a quirky phenomenon on a playground ride, it has significant implications in the real world. In the case of the merry-go-round, the rotating frame of reference is the spinning platform. This same principle applies to much larger systems. Because the Earth is constantly rotating, the Coriolis effect also influences large-scale weather patterns, ocean currents, and even the flight paths of airplanes and helicopters. Now, how does this relate to helicopters? Let's dive into that. As the helicopter's rotor blades spin, different parts of the blade travel at different speeds due to the rotation. The blades moving in the direction of the helicopter's rotation are actually traveling faster than the blades moving against the rotation. This creates a complex dynamic. This difference in speed creates a difference in inertial force due to the Coriolis effect, causing the blades to flap unevenly. This uneven flapping can affect the stability of the helicopter. To compensate for this uneven flapping, helicopter rotors are designed with hinges that allow the blades to move up and down independently. This is a crucial design feature. This flapping motion helps to counteract the Coriolis effect and maintain stability during flight. It's a delicate balance that engineers have perfected over years of innovation. So, the next time you see a helicopter gracefully maneuvering through the air, remember that it's not just battling gravity, but also contending with the invisible forces of the Coriolis effect. It's a marvel of engineering and physics. But wait, there's more! The story of helicopter flight doesn't end here. We still need to uncover the secrets of gyroscopic precession, another fascinating phenomenon that plays a crucial role in helicopter flight. Stay tuned for more. Have you ever played with a spinning bicycle wheel? It's a simple, yet fascinating activity that can teach us a lot about physics. If you have, you've probably noticed that when you try to tilt the spinning wheel, it doesn't tilt in the direction you expect. Instead, it seems to have a mind of its own. Instead, it tilts in a perpendicular direction. This unexpected behavior can be quite puzzling at first. This peculiar behavior, my friends, is called gyroscopic precession. It's a fundamental principle in the world of rotational dynamics. Gyroscopic precession occurs because spinning objects, like our bicycle wheel or a helicopter's rotor blades, possess a property called angular momentum. This property is crucial for understanding how these objects behave. Angular momentum is a measure of an object's tendency to keep spinning about its axis of rotation. The faster it spins, the greater its angular momentum. Now here's the cool part. When you apply a force to a spinning object, like trying to tilt it, the applied force doesn't cause the object to tilt directly in the direction of the force. Instead, the force is felt 90 degrees later in the direction of rotation. This means the object responds in a way that might seem counterintuitive at first. This delayed reaction is due to the conservation of angular momentum, which dictates that the spinning object will resist changes to its axis of rotation. It's a fascinating interplay of forces. So, how does this apply to helicopters? Well, when the pilot wants to tilt the helicopter forward, backward, or sideways, they don't actually tilt the rotor blades directly. Instead, they use the control stick to create a force that acts on the rotor mast. This force, due to gyroscopic precession, causes the rotor disc to tilt in the desired direction, allowing the helicopter to maneuver. This principle is what makes helicopters so versatile and capable of performing complex maneuvers in the air. It's all about understanding and harnessing the power of gyroscopic precession. By mastering these controls, pilots can make precise adjustments to the helicopter's orientation and direction, ensuring smooth and controlled flight. This force, due to gyroscopic precession, causes the rotor disc to tilt in the desired direction, allowing the helicopter to maneuver. It's a delicate balance of forces at play. Now that we've covered some of the key physics principles behind helicopter flight, let's see how these principles come together to allow helicopters to achieve vertical and forward flight. Get ready for takeoff. Understanding these principles not only helps us appreciate the complexity of helicopter flight, but also opens up a world of possibilities in the realm of aviation and beyond, so buckle up and enjoy the ride.